Sequences. Vocabulary. Multiple. A number that can be divided exactly by another number is a multiple of that number. When you start at 0 and count up in equal steps, that is counting in 2s, 3s, 4s, etc., you will find the numbers that are the multiples of the step size. Over here I have taken an example of the multiples of 3. I start from 0 and start jumping in steps of 3. So this 3, 6, 9, 12, etc. are all called as the multiples of 3. In the same way, when you start the counts from 0 to 4, we get 4, 8, 12, 16, etc. which are the multiples of 4. Let's investigate. Use the clues to find the sixth number in this sequence. Let's see the clues. The fourth number is equal to 3 tensa. 3 tensa is 30. So the fourth number is equal to 30. So next clue. The second number is equal to 10 plus 6. The second number is 60. Third clue. The third number is halfway between the second and fourth number. So what would be the halfway between 16 and 30? You have already learned to find out the halfway. To find the halfway between the two numbers, first step is you need to subtract the two numbers. That is 30 minus 16. We get 14. Second step is that you need to divide it by 2. So 14 divided by 2 gives you 7. So add the answer to the first number, that is 16. 16 plus 7 gives us 23. So the third number would be 23. Fourth clue. The fifth number is 7 more than the fourth number. We know that the fourth number is 30. So 7 more than 30 gives us 37. So now we need to find the last number in the sequence. When you observe the sequence, you see that each number is moved in steps of plus 7. So 9 plus 7 gives us 16, 16 plus 7 gives us 23, 23 plus 7 gives us 30, 30 plus 7 gives us 37. So what is 37 plus 7? Is 44. So the sixth number in the sequence is 44. Question 1. Identify the number sequence shown on these grids. When you observe the grid, you see that every fifth digit has been colored. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the number sequence on the grid are the multiples of 5. When you observe the second sequence over here, we see that every second number has been shaded. So 1, 2 is shaded, 3, 4 is shaded. So this would be the multiples of 2. Question 2. The grids at the top of page 7 have been toned so you can only see part of them. A. What multiples have been shaded? When you observe grid, we see that this is shaded in the multiples of 5. 1, 2, 3, 4, 5. So this is shaded in multiples of 5. Let's see with the grid 2. We find that it's been toned to both the sides. So let's find the multiples by looking at the numbers between two shaded parts. 1, 2, 3, 4. So it's been shaded in terms of multiples of 4. This is the answer for A. Now let's work on for B. How wide might the grid be? Here I have extended the grid 1 to find how wide it could be. So the grid would be 1, 2, 3, 4, 5, 6, 7, 8. 8 squares wide, or 9, 10, 11, 12, 13 squares wide. to complete the sequence of multiples of 5. Just observe the pattern shaded over here. So, fifth, 10, then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So, it could be 8 squares wide or 13 squares wide. Let's work with the grid 2. When you observe the grid 2, here I have extended the grid to match the multiples of 4. So this grid would be 1, 2, 3, 4, 5, 6, 7 squares wide or 8, 9, 10, 11 squares wide to complete the shaded part of multiples of 4. Do remember that the grid continues to extend in the same way. I have just written 2 of the possible width. Question 3. I have just written one of the sequence. When you observe the sequence, you have 2 of the numbers next to each other. Let's check how it has increased. So 49 plus how much gives us 53. When you observe the sequence, that it is plus 4. Right? So the sequence has increased by adding 4 to each number to the left. So let's write or complete the sequence. This is the rule of the sequence. So we see that the number next to 53 would be 54, 55, 56 and 57. So let's complete the forward count and finish the sequence. The next number would be 65 and the last number would be 69. So over here we need to backward count to find the previous numbers. So minus 4 of 49 is 45. 45 minus 4 gives us 41. This is the way you need to complete the sequence. Do work out with B and C. Question 4. This is an 8 by 8 number grid. Ask the teacher for a printout. So you can shade it over here only. On your copy of grid, color the multiples of 7. Let's color the multiples of 7 now. Question B. What do you notice? We notice that the numbers shaded form a diagonal path, right? We see that the numbers that are shaded form a diagonal path. See, if you continue the sequence, would 100 be in the sequence? So we can say no, because 100 is not the multiple of 7, right? So D is 105 in the sequence. How do you know? We can know it when we divide 105 by 7. So when you divide 105 by 7, we see that 7 15s is 105. So definitely 105 would be in the sequence. Do work out with question 5 and 6 in your learner's book on page number 7, which will be discussed in the online class.